Let's have a look at question 6 in this video. So we want to prove whether having a global maximum necessarily means that we're going to have a stationary point, meaning that the derivative is going to be 0. So let's draw it on a graph and see if that's true or false. And the domain of our function is going to be defined, it's going to be a closed domain, meaning that x takes a range of values. So suppose this is our xy axis. And let's say that our domain for x is between the values of 1 and 5. So x takes values between 1 and 5, meaning that on our graph, our values that we take into account are from here until here. And let's say that the graph itself looks something like this. So for example, it starts at this point where the value of f of 1 would be, let's say, 3, and it has the following shape until here, and the value at f of 5 is going to be equal to 10. Okay, so what do we see here? We can see that we have local maximums and a global maximum. Remember, what is a local maximum? It's basically when we have a stationary point where the function, the derivative of our function, is 0, and we can see that it's a peak. So basically it's a relatively higher value than the values around it. And we have a peak here, we have one more peak here, but the highest value of the function, the highest value that this line takes, is all the way up here, which is the value of 10 in our example. Now the question is this a stationary point as well? Is this a derivative equals to 0? Well, no, this is not a derivative equals to 0. This is just a slope that is increasing, and that's it. It's not flattening out. So when we have a function that is defined on an interval, we could have the case that the end point, meaning the last point in our domain for x, which is 5, leads to the highest value. It leads to the value of 10 in this case. So the answer would be, by proving it on a graph, that no, we do not necessarily need a derivative equals to 0 to have a global max on a closed interval. It could be that the endpoint is going to be the max. I hope this makes sense.